Welcome all. So today we will be solving one of the problems from TIFR 2019. So which basically the basics of a minimal polynomial. So if you know minimal polynomial, then you know how to solve this. Okay. So there are two observations. It will be quite a short session. So there are two observations that you have to make here. So the first thing is that if P of A is equals to 0 for any monic polynomial. So monic polynomial means the leading coefficient is 0, px. Then the minimal polynomial mx divides p of x. So this is as far as it goes. And another that the reducibility and or irreducibility of a polynomial sometimes depends on the field. So why do I say that? So one thing is here that you can actually see that you have been given M10R. So we are taking it as a real vector space, right? So now a square plus a plus I, if you take the polynomial x square plus x plus 1, so just take the corresponding polynomial x square plus x plus 1. So now this has roots omega square, right? But if this polynomial has to be reducible, that means if you want to write it as x minus omega square, then individually both these things has to be inside cx. Okay, so generally the roots belongs to c, and thus this polynomial is not reducible over R. Okay, so this polynomial cannot be reduced over R. So now the fact is that since a square plus e plus I is equals to 0, this implies the minimal polynomial of the same matrix divides this, let's say, P of A. If P of A is then let's say the minimal polynomial divides P of X, right? So now then the minimal polynomial has three options, either x minus omega or x minus omega square or the P of X itself, right? Because that is how it is kind of breaking up into. So the factors are x minus omega square, or the product of their entire thing. Now the minimal polynomial has to be a polynomial of real coefficients. That is the property of the minimal polynomial. So the minimal polynomial is the least degree monic polynomial with coefficients in F. So F means over which your vector space is defined. Okay, that divides the characteristic polynomial. polynomial and m of a is always 0. So this is the definition of a minimal polynomial. All right. So here what we have is that the minimal polynomial can only be this or the entire px, but neither x minus omega, x minus omega square lie in R. Okay, so the moment they do not lie in R, the minimal polynomial itself becomes the px. So the minimal polynomial is itself x square plus x plus 1. Now, one of the consequences of a polynomial being the minimal polynomial is that, so I'm writing min m poly. Okay, so m poly always contains all the eigenvalues of the matrix. Okay, this is one of the very useful property of minimal polynomial. So the moment the minimal polynomial is x square plus x plus 1, so you know that the eigenvalues of your matrix is omega and omega square. So there are no zero eigenvalues, and thus this matrix is indeed invertible. Hence, this is true. So that's it for today. Thank you for joining. We will meet with another problem in the upcoming session. Thank you.